Hello everyone, welcome to this tutorial on how to perform a chi-squared test in R. This tutorial assumes that you already know what a chi-squared test is and that you know what kinds of data it applies to. So let's jump straight in. Now I'm going to be using in this tutorial the Rstudio platform. In particular, I'm going to use the Rstudio platform in the cloud, which you can access from your browser, your internet browser. So let's do that. So let's go over to Google and type Rstudio Cloud. There it is, the first link on the left. And then let's log in. Anyone can get a free account with this program, but you may already have Rstudio installed locally on the computer. So I'm going to log in with Google. My account. Perfect. Here we are. Okay. So now we want to let's make a new project. Rstudio project. Now while that's deploying, let's go and get some data. So the data set that I'm going to use for this tutorial is saved at the UCI machine learning repository. There it is, the top link. And when you click on that link, it'll take you to this website, which is essentially a repository of lots of different data sets that are useful for data science. Now over here on the right is a yellow link, View All Data Sets. I'm going to click that link. And then in the menu on the left, I'm going to scroll down and click Life Sciences. And then I'm going to scroll down till I see this data set called Heart Disease. Now on this page are lots of pieces of information that are useful for analyzing this data set. So for example, there are missing values involved. There are 303 records. There are categorical, integer and real variables. And it was donated in 1988. If I scroll down, I can see a brief description of the data set itself. If I scroll down a bit further, I can see a list of the variables we'll find in the dataset. So let's go and download that data. So if I go to the data folder, I'm going to find this list of data files. Now what you can do is you can click on any one of those and it will open or download the data file for you. I'm going to use for this tutorial processed Cleveland data. So you're going to right click and copy that link. So now let's go back over to Rstudio Cloud, where we're welcomed by the console on the right. And what we're also going to do is open a new RScript file by clicking on this green plus icon in the corner. There we go. So now the first thing I want to do is import packages. The only package I'll use for this tutorial is the tidyverse. So let's import the tidyverse. Oh, and it's complained. There is no package called tidyverse, so I forgot to install it. So to install it, I type install.packages, and then in quotes I type tidyverse like this, and run it. And that's going to download some things. So let me pause the video while that installs. Cool. So you can see now, I've skipped ahead a bit, but you can see now the downloaded source packages are in this temporary folder. Alright, and we can check by typing library tidyverse, running it, and you can see now that it's installed properly. So let's take that line, copy it, paste it up here so that we remember it for next time, and let's save this script to something useful. Let's call it chi-square test.r. When I hit Ctrl N S to save there. Alright, so now we've installed the packages, we need to import the data. So what I'm going to do first is type read.csv, and in here I'm going to put the URL. So I'm going to go back to my machine learning page, copy this link, paste it in there. So let's run it and see what happens. Okay, so it's downloaded the data, but you can see that at the top, the first value of each column has been used as the title for that column, or the variable name. We don't want that because we want to keep those values as data entries. So I'm going to pull out my command I just ran and change it such that header equals false. You can see what this does at the top now. Each column is given its own different name, and the first values of each column are now where they should be. Alright? Perfect. So I'm going to save this. First of all, I'm going to pipe it to the asTibble function. That's going to make it into a tibble, which is a bit nicer to use. I'll show you what that looks like. There we go. And then I'm going to save that to something. Let's save this data frame as heart disease data. And you can see now over on the right, this data frame called heart disease data has appeared. If I double click on it, it gives me my data. There's a spreadsheet. Alright. So what I'm going to do in this video, we go back over to the description of the data, is I'm going to look at correlations between the sex of the patient and then the predicted attribute, which they've labeled num. So num represents the presence or absence of heart disease, where in the description explains that 0 is no presence and values 1, 2, 3 and 4 are presence to some degree of heart disease. So let's do that. The first thing I want to do is to look at my data and make sure everything makes sense. So particularly I'm interested in columns 2 and 14, which is sex and num respectively. So heart disease data, let's look at column 2 first. 2, you see it's a list of values, 1s and 0s, and R has guessed that it is a double value, which is not right, so we'll have to change that. I can see a bit more about this variable. I can look at all the values at once by piping this to asList, and here it gives me an overview of every single value in the dataset for that column. And you can see there are no missing values, and there are no values other than 0 and 1. So that's good. So let me take that command and copy it into the script at the top. I can also type if I want to, instead of asList, I can also look at the range. And the range is between 0 and 1. So we know that the values are between 0 and 1. So let's copy that there. Okay, so the next thing I want to do is look at variable 14, which is the other variable I'm interested. And I'm going to do the same thing. Heart disease data, pipe it to the select function, and I'm going to select variable 14. Let's have a look. So the values are 0s, 2s, 1s, 3s, 0s, who said 0s? And R has expected that it's an integer, has treated it like an integer. So let's look at all the values at once as .list. This command is useful for small data sets but not useful for big ones. And you can see there are no missing values, and the values are either 0s, 1s, 2s, 3s and 4s. So let's copy that. And we can do the same thing we did before, where we look at the range as well. And the range is between 0 and 4. So that's what we expect. So I'm going to put that up there. Okay. So now I've got my data, I've looked at it. What I want to do is clean it up and tidy it up and prepare for analysis. So the first thing we notice, if we look at the sex column, is that it's a series of 1s and 0s. However, we would rather have this to be a bit more informative. So if we go over to the information page again, you can see in the encoding that 1 is male and 2 and 0 stands for female. So what we can do is we can add a new column which includes this explicitly. So I'm going to use heart disease, pipe that to mutate. I'm going to create a new column called sex_mf, and then I'm going to use the if else to specify the values in this column. and I'm going to say that if variable v2 equals 1, then SeXMF column is male. Otherwise, it is female. So let's quickly look at that. And you can see, to be clear, that we've created a new column, SeXMF, on the far right hand side, which has values of male when v2 is 1, and it has values of female when v2 is 0. Cool. That's a good data frame to work with, so let's save it as something, and in fact, I'm just going to override the original data frame. There we go. So if I have a look at heart disease data again, you can see it's got this column now. Alright, so let's take that line and copy it and paste it up into the work notebook at the top. Very good. Now I want to do something similar, but for variable 14. So remember I discussed before that 0 refers to the absence of heart disease. Values 1, 2, 3, 4 refer to the presence of heart disease. So for a chi-square test, we would like to dichotomize this variable, i.e. we would like to make it only have one of two different values. So what I want to do is I'm going to say, I'm going to create a new variable. Again, I'm going to use mutate. I'm going to create a new variable called heart disease. That's going to be, and we'll use if else again. And we're going to say that if variable 14 equals 0, then we're going to say there is an absence of heart disease, else we're going to say there's a presence of heart disease. Let's look at that now. Oh, it's chopped it off the end. So let's use the select function to look at that variable. So let's look at variable 14 together with heart disease. Here we go. Let's run it. There we go. So you can see that when variable 14 is 0, heart disease is absent, and when variable 14 has any other value, you can see the word presence. Very nice. One last thing I would like to do is to change this variable, because you can see R has labeled it as a character, and in fact we would like it as a factor. So I'm going to put as.factor in there. I'm going to run it, and you can see it's the same, but now R treats it like a factor. Alright, that works. So let's take that whole data frame there and let's overwrite again. So we can go over to our spreadsheet if you like. And you can see we've got a new variable, SeXMF and heart disease. Perfect. The last thing I want to do is change its swap. Now I want to copy that, paste it up here so I don't forget it later. And I also want to make this a factor as well, so I'm going to do the same up here. There we go. Now let's see if that works. Run that line. And let's have a look. Where are we now? Let's use data, select, and let's look at V2 and sex. Oh, sorry, SeXMF. And you can see that's now a factor as it should be, not a double. Okay, cool. So data set's clean. Now we can start to do some analysis. So first what we want to do is summarize the data in a table. So I'm going to type heart disease data there. I'm going to group by, and then I want to group by new columns I've created, SeXMF and heart disease. Then I want to summarize by counting them. And there's my table. So you can see the number of females with no heart disease is 72. The number of females with heart disease is 25. The number of males without heart disease is 92. And the number of males with heart disease is 114. Before this, I can also have a look at sexes by themselves. So let's see what the distribution of males are to females. You can see that there are 97 females to 206 males. So there's a lot more males than females. So let's just copy that now. And then we can also draw that. We can also have a look at that. Let's plot. So let's run heart disease data. And pipe to ggplot. AES. And the x-axis is going to be sex mf plus geon underscore bar. There we go. And you can see the plot that's just appeared in the right hand side of the screen shows us what the table also described, which is that there are many more males than females. So let me take that line, place it there. Alright, so now let's go back to the table we drew above, which was heart disease data. And let's do group by sex, MF, and heart disease. Then summarize with count. Count equals n. Right, that's the table that we showed before. So now what we want to do is draw a histogram where we can see the proportion of females that have heart disease versus the proportion of males that have heart disease. So what we're going to draw is a 2 by 2 table. So this table is almost there, but first we've got to pivot it wider, pivot wider, names from sex mf, values from count, like this. Names not from sex mf, so names from heart disease, values from count. Let's have a look. There we go. So now we've got a 2 by 2 table with female and male on the left hand side and absence and presence on the top. So if any of you recognize the 2 by 2 table there, you'll know that this is exactly what we need to do a chi-square test. So let's take that line, copy it, and then let's save it by putting it back in the notebook up there. Now, let's take that line and let's draw a bar chart. So I'm going to pipe that to ggplot. AES, along the x-axis, we have sex MF. On the y-axis, we want to be, let's have a look at presence divided by presence plus absence. Right, it's giving me an error because in here I need to have stat equals identity. That gotta be right. Yeah. So now you can see the plot on the left hand side shows that there is, let's add one more thing to the plot, plus y-lim, so let's show its scale between 0 and 1. There we go. You can see that more than 50% of the males in the sample had heart disease, whereas only 25% of the females had heart disease. So we would expect now, let's first of all save that command there. Given that plot, we would certainly expect to see a p-value a significant p-value from our chi-square test. So let's do the chi-square test. I'm going to run chi-square test. There you go. And in here, I'm going to put the x, which is sex. Oh no, sorry, which is heart disease data, sex, MF, and in here, heart disease data, domicile, and then, what do we say, heart disease. That's right. Cool, and you can see now that we do obtain a p-value which is significant at 2.667 times 10 to the minus 6. And that agrees with the plot that we just drew. So that's it. We had a look at the data. First of all, we had a look at the data. Then we created some new columns that were easy for analysis. And then we drew some tables and some bar charts to summarize the data. We drew a 2 by 2 table. And then we plotted the 2 by 2 table over here. And then finally, we did the chi-square test itself. And you can see the p-value is certainly significant, which agrees with what we can see on the right hand side, that proportion of males with heart disease is much greater than the proportion of females with heart disease in this study. Cool, thanks very much. That will be the end of the video. Please leave comments and questions in the description below the video. Cool, thank you so much. Yep, and I hope this helps.